this is Mr. Manley. In this video, I'm going to cover both the law of sines and the law of cosines. First things first, you'll want to take down all of the formulas that are on this page. I presume that you are familiar with them. Anybody who is taking precalculus, took geometry, and law of sines and law of cosines should have been covered in geometry. We're going to go into this with a little bit more depth today, and I hope you get something new out of it. Of course, when we are working with triangles, you are knowing that the angles are labeled by capital letter and the sides are labeled with lowercase letters. And we also know that the angle is placed on the opposite from its side. And with those ground rules laid, let's take a look at a problem. A couple of things about this. One is when it says solve, that means we're going to find the measure of every side and every angle that we don't know. And as you can see here, we're given some information. And in order to be able to solve, in order to be able to find the measure of all of the sides and all of the angles, we have to be given three pieces of information. Some combination of angles and sides in three parts, or three pieces. So here we've got two angles and a side. Hopefully you understand that for our purposes of solving a triangle, if you're given two angles, the first thing that you'll do is find the third angle by using the rule of 180. So we'll do that for angle C. Another thing is maybe we've been working in either degrees or radians with our angles in trigonometry. Here we're going to stick to degrees, no radians when we are solving triangles. And then obviously this is angle C is equal to 180 degrees minus 109 degrees minus 29 degrees. And we get 42 degrees, and that's simple enough. Next, we're going to find one of these sides. Doesn't matter whether we go side A or side B. Notice when we look at the formulas for the law of sines that we can put the angles in the numerator or we can put the sides in the numerator. Whatever I'm going to be solving for, that's what I'm going to put in the numerator. So since I'm going to solve for a side, either side A or side B, I'll do side A. I'm going to put side A in the numerator. So that'll be A over the sine of its angle, which is 109 degrees, equal to C is the side that I know, so I have to use that, over the sine of its angle, which is 42 degrees. And then we'll solve this for A. That'll be a very simple calculator key-in. We get side A at 41.0. And then side B over the sine of its angle is equal to, again, we'll use side C over the sine of its angle, which gets us 21. Something that I didn't do here that I actually want to do for each of these triangles is I don't want to use the triangle that's given. Because notice here, this triangle is given to me within the text of the problem, but angle A is supposed to be 109 degrees. And this angle in the triangle is clearly, it's acute. It's not even obtuse. So I'm always going to start off by drawing my own triangle. I usually put one of the angles that I know in the bottom left-hand corner, and then I build off of that. A 109 degrees. And then I'm going to have B at 29 degrees. Maybe I'll do that down here. And I want to get a nice small angle there for 29 degrees. And then I will label side C here at 29. And then if I draw that triangle, now I can look and see, do the other measures make sense based upon the drawing of the triangle that I've done. For instance, A is supposed to be a length of 41, and B is supposed to be a length of 21. And those measures and how they relate to each other all make sense based upon the drawing that I've done. So let's take a look at that on the next one, and I'll start off with the drawing. Oh, actually, before I do that, let's take a look at this idea of getting three pieces of information. So here in this problem, I was given an angle, I was given a second angle, and we were given this side here. So reading that, I was given an angle, a side, and an angle. ASA. Going to my table that we just saw pop up, which reminded me what I wanted to do, that's showing up here. And we use the law of sines. Now, actually, the first thing we did was find the third angle, and then we use the law of sines. For AAS, I can find the third angle and use the law of sines. For ASS, I can find one of the other sides. We'll take a look at that one next. If I have SAS, if I'm given a side, an angle, and a side, I cannot use law of sines. I will have to use law of cosines. The same with SSS, if I'm given three sides. And for AAA, neither. Because AAA is not a unique triangle. If I know three angles, the sides can still be any measures. So these are all the ways that the three pieces of information can be given and which law I need to use in order to solve the triangle. Maybe we'll keep referring back to that. Let's go to this one and take a look. And let's think about this one in those terms. I'm given side B, I'm given side A, and I'm given angle B. That's an ASS. Angle, side, side. Right there. Like I said on the previous problem, I really want to draw my own triangle. Because look at this angle B here. Angle B is 105 degrees, and I don't even have an acute angle, an obtuse angle there. So I'm going to draw my own triangle. Again, I like to do my first angle in the bottom left-hand corner. So I'm going to do angle B down here like this. I'll call that 105 degrees. Angle B. And then side B is across from angle B. And side A is supposed to be longer than side B. So I'm already seeing a problem here, right? Is there any way that side A could be longer than side B? There's no way I can have an angle that's more than 105 degrees, because if I have an angle that's more than 105 degrees, that's more than 180 degrees total. So we got a triangle here that is not possible. Let's take a look at what happens if we try and solve it. So what would I do? If I were not paying attention, I would say, okay, B is equal to 43, and then say I put side or angle A up here, and then side A is 64. And I've got a picture here that doesn't make sense. Let's look what happens when I try and solve. I'm going to have to solve for the angle A based upon the information that have been given. So I'll set up this equation. And sine 105 over 43. Okay, so that'll be A is equal to sine 105 degrees divided by 43. Then I would be multiplying by the 64. And to solve for A, so that I isolate A, do you understand? I'm going to have to do the inverse sine. So I actually want to give myself a little space here. And I'm going to do the inverse sine of this. And that's what A is equal to. All right, and then doing the calculator key-in for this, what do we get? We get an error when we plug that into the calculator. And just like our picture was showing us, this information that they've given me is impossible. I can't make a triangle out of that. And the way we would respond to that, we would just say no solution. This triangle is not possible. Let's move on to another ASS case. Again, I'm going to start off by drawing my own triangle. I have the 35-degree angle that I'm going to do down here in the left corner for angle B. And let's see, angle or side C I'll put up here, a length of 46. And then the side B opposite that is going to be down here. B equals 36. Solving, I'm going to solve for angle C, right? So it's going to be sine C, which is what I'm looking for. I'm looking for angle C, so sine C over 46 is equal to sine of 35 degrees over side B is 36. So C is equal to the inverse sine of all of this sine 35 degrees over 36 times 46. And let's see what that equals. And that's 47.1 degrees. And then I would be able to find angle B or angle A by the rule of 180. And I'd be able to find sine, or I'd be able to find side A by using the law of sines. But there's something that we have to pay attention to here. Let's go back to our list of triangles. If ever in this list of triangles we are dealing with this case, we have to be careful not to assume. And it's only this case. It's only the ASS case. So that's why I write it like this. ASS for assume. ASS for assume. Do not assume. In an ASS case, there may be two possible triangles. And it will only be possible, not guaranteed, it will only be possible if the given angle is acute. So going back here, this given angle is an acute angle, and that's the only angle I'm given. If that angle is acute, so this is what we're keeping track of, that it's an ASS case and angle is acute, less than 90 degrees. If that is the case, ambiguity is possible. And do you know what ambiguity means? That means it's not certain. It's not definitively one answer. So in this case, what's going to happen is I am going to always, when I have an ASS case, it's an acute angle, and I find one angle, I'm going to see, should I call that just the first possibility? And then the second possibility, which in this case will be C2, is 180 degrees minus the first possibility, which in this case was the first possibility is 47.1. So I'm going to do that calculation, and I get 132.9 degrees. So watch what I'm going to do up here. I'm going to erase this information now, and I'm going to draw myself another triangle. So this other triangle is also going to have B at 35 degrees. It's going to have C at 46. And then it's going to have this angle C coming in here at 132. So think about where you would draw that. Can you see where I would draw that? Remember, we don't really know what this side is yet. So I extended that more than I needed to. So I'm going to bring that back. And then I'm going to draw a line in here. And that's going to give me a C2 of 132.9 degrees. And then from there, I'll be able to find a new angle A, which will be A2. And back over at this other triangle, that's A1. So I'm going to have two solutions, two sets of solutions. And this can only happen if I have an ASS case with an acute angle. It's not guaranteed to happen. There are a couple of ways that it might not happen. One way is that I might end up with an angle, a side and an angle that just creates a right triangle. And then that's the only possibility. I can just make that one right triangle. And then the other possibility is it might be another no solution case. Remember the no solution case from the previous page? It's possible that I could have a ASS with an acute angle that is no solution. So that's the major instructional point here. The ambiguity, and the ambiguity when I have ASS or an acute angle. I'm not going to go in and solve for the rest of the sides and the angles. I can leave that to you. But you do need to be aware of this ambiguity. So going back to our table, we've really just looked at the law of sines here. And I don't want to extend this video any longer. So we've looked at all of these cases, or talked about all of these cases. Next up, which I will cover in a separate video, is what happens with these cases. And quite simply, we can't use the law of sines to solve these. We're going to have to use the law of cosines. And I'll do another video where I look at a couple of those cases.